Hello class, and welcome back to Holbert Helps. My name is Mr. Holbert and I will be your teacher. Today's topic is factoring by grouping. Factoring by grouping is this idea right here where we take a polynomial, in this case a quadratic, and we factor it into separate parts, into separate groups. So this tends to be the factoring that most students struggle with. I will have another video about factoring out common factors, but I didn't want to do them both in the same video as it would be too long. Okay, before we even get started though, I'm going to be using the generic rectangle and diamond method. If you don't know what a generic rectangle is or how to use it, I suggest you watch my distributive property video. I go over it in there and you can watch that and get an understanding and come back here. Besides that, let's talk about what diamond problems look like really quick. Right here is a diamond problem, and how it works is that you have a number here represented by A and a different number here represented by B. The bottom number is found by adding A and B together, and you get that. The top number is found by multiplying these two numbers and getting the top. So in my example over here, I have 2 and 3. So if I do 2 times 3, that'll give us the top number, which is 6. And if I do 2 plus 3, that gives us the bottom number, which is 5. It's a simple idea. Sometimes these diamond problems can get really tricky, but we're actually going to be using it in the reverse in this video, where instead I give you the 6 and 5, and you have to find these two numbers. And you'll see what I mean when we get to that first problem. With that being said, let's go ahead and just get started. Okay, class. Now we're ready to start our first problem, which we have over here. We're going to factor 4x squared minus 8x minus 12. So to get started, first things first is we need to make our generic rectangle. So I'm going to make a generic rectangle, and I'm going to make it like this. Okay, now that I have our generic rectangle set up, what we're going to do is we're going to take this number here, and we're going to write it here. So we got 4x squared, and write it in the bottom left. Then we're going to take this number, and we're going to write it in the top right. So we got 4x squared, and we got negative 12. Now there's one part of our quadratic here that we haven't really used yet, which is the negative 8x. And the reason why we haven't used it is that there is some combination of numbers that add up to negative 8x. Now, there are a ton of different ways to get negative 8x with just whole numbers. So to stop from it being a guessing game, we're going to use our diamond problems. So let's go ahead and come over here, and we're going to make our diamond problem. We're going to start off with it. The top of our diamond problem. The top of it, we're going to take our first part of our quadratic, and we're going to multiply it by the last number in our quadratic. So we're going to do 4x squared times negative 12, which gives us negative 48x squared. Now that is our top part. So I'm going to come over here and write that, negative 48x squared. For our bottom part, well, I just talked about how we need two numbers that adds up to negative 8x. So that's going to be our bottom. And we're not going to do anything to it. We're just going to take it and just write it over here. Make sure that you guys are watching your signs and that you bring the negative with it. And whenever we're doing this method, it'll always follow that pattern. For the diamond problems, we take the first, multiply it by the last, and that goes on top. And then we take the middle one, and that is what goes on bottom. And what this does is it takes the guessing game out of it. Instead of us being like, oh man, what two numbers possibly add up to negative 8x? We can use this as a way to guide us. So I always suggest that you try and figure out what works for the top before you come down to the bottom. So I have negative 48x squared. And since it's a negative, I'm going to have a positive and a negative number. And right now, looking at it, I can tell that it should be negative 12x and positive 4x. And if we check here, negative 12x times 4x does give us negative 4x squared. Negative 12x plus 4x gives us negative 8. So we can come over here and write that. And that is what goes into our other two spots. Find those two, write those two things in our generic rectangle. Now, when it comes to solving the diamond problems, there is no perfect way to finding these two. There's no formula, there's no special secret technique, nothing like that. You can use process of elimination, and I suggest you always try to find what two numbers multiply to the top, because once again, tons of things can add to the bottom. That's why we're doing the diamond problem in the first place. So try to multiply first. And as you get some practice, you'll find that you get pretty quick with it. Now, we're not done. We're only set up now. So what we're going to do is we're going to find the outside of our generic rectangle. So we're basically working backwards. Okay, let's start trying to figure it out. So what two numbers multiply into 4x squared? Well, we could do 4x times x. That would give us 4x squared. Okay, now let's test the rest of our problem here. 4x times something gives me positive 4x. So if I think about that, the only thing I can do is 1, excuse me. So we'll write 1 there. X times something needs to give me negative 12x. Well, there's only one possibility, and that's negative 12. So if we check here, negative 12 times 1 does in fact give us negative 12. So we found the base and the height of our generic rectangle. Now we're still technically not done yet, but there's only one more thing we need to do. We need to rewrite our base and our height outside of our generic rectangle. So we're going to do 4x minus 12, close the parentheses, and then we're going to do x plus 1, close the parentheses. Okay, and now we have successfully factored this problem. Now, if you get to this point and you're a little worried, like, hey, did I factor this properly? You can use your generic rectangles the way that we normally use it for distributive property, and you can test and see if you get the original problem out. So I'm going to write 4x minus 12 and x plus 1 here. So 4x times x is 4x squared. 4x times 1 is 4x. X times negative 12 is negative 12x. And negative 12 times 1 is negative 12. As a reminder, we're going to take all of this and we're going to rewrite it outside of our generic rectangle. So we're going to take 4x squared minus 12x plus 4x minus 12. Combine like terms. So 4x squared doesn't have anything to combine with. We can combine these two to negative 8x minus 12. And if we check if that is the same as our original problem, sure enough, it is. So we did factor properly, and this is our final answer. With this problem, we could factor out a common factor from this first one. We could factor out a 4, and we could get another answer of 4 out here, x minus 3, x plus 1, and that could be another answer. Now, that's not really needed unless your teacher is really insisting that you factor out that common factor, but we don't usually factor just for fun. We usually do it to find something else, and usually when we get to this point, we're able to see it. So this is a good final answer. Okay. There, we went over our first example. Lots of steps, right? But by using this generic rectangle, the diamond problem, it streamlines the process a lot. And it gives you a way to consistently get the correct answer each time. All right, with that being said, let's move on to our second problem. And then we're going to set up our diamond problem over here. So let's do that. All right. Diamond problem, multiply the first by the last, and we get 4x squared. So let's come over here and write that, 4x squared. And then we take the middle term and we just write it how it is, 3x. Okay, so I need two numbers that multiply to 4x squared but add to 3x. So they have to be either two negatives or two positive numbers to multiply to a positive 4x squared. So let's start running through some possibilities. We have 2 and 2, which that multiplies to 4, but it doesn't add to 3, okay? Negative 2 times negative 2, once again, that multiplies to 4, but doesn't add to 3. let's see here, positive 4 and positive 1. Once again, multiplies the 4 but does not add to 3. So we can keep doing this, but long story short, guess what? It's not possible. It is not possible to find two whole numbers that multiply to 4 but add to 3. So if you get to a diamond problem and you're going through it and you cannot find an answer to your diamond problems, then guess what? If your goal is to only factor, you're done. It is actually not factorable. It's not factorable with whole numbers, with our rational numbers at least. So I need to be careful with this idea of things not being factorable, because there are two numbers that work here, but they're going to be super ugly numbers. They're not going to be nice whole numbers. And when we're factoring, the whole point of us factoring is to make it easier to work with. We don't want to make it more complicated. So how you know it's not factorable is you set up your generic rectangle, set up your diamond problem, and then if there is no possible combination to put here, then it's not factorable. If, excuse me, if you're sitting here for a while and you cannot seem to find the answer, be careful, it might still be factorable, you just can't find it. So this is where it gets kind of tricky, is it's like, can I not find the answer, or is it not factorable? And the only thing I can really say with that is it takes practice. You'll learn to identify when things are not factorable and when they're just really tough. Positive on top and bottom, that tends to be not factorable, especially if the numbers are really close, but always double check. Always double check, okay? But this one is not factorable by grouping. So we're actually done. Super short example 2, but I wanted to show you guys something that is not factorable. So let's move on to problem 3. All right, class, here is problem 3. Before we get started on it, I suggest that you guys pause the video here and that you try to solve it on your own first, and then continue the video to see if you did it properly. So to begin, we got our generic rectangle. Same thing, as always. We're going to take our first number and we're going to write it 16x squared. Take the last number, our constant, and write it in our top right. Okay. Now we need to come over here and make our diamond problem. As a reminder, we take the first part and we multiply it by the last one. So we got 16 times 6, and I'll be honest, I don't know that one off the top of my head. So let's go ahead and do it. 16 times 6. Okay, 96, and it's a negative 6 at that, so negative 96x squared. Perfect. Negative 96x squared. And then we take the bottom integer just as it is, and we're going to write negative 20x. Okay, now we need two things that multiply to negative 96x squared and add to negative 20. As a reminder, you should check multiplication first. So let's see here. What possibly multiplies to negative 96? Well, 3 goes into it, so 3 times 28. And this is a part where when you have large numbers, I suggest use a calculator and you start testing it. So we take 96 and you should start dividing it by numbers. Is it divisible by 3? It is. 32 and 3 go into 96. So we could test that if we wanted to. 32 will make it negative times 3 goes into 36. But if I add these two together, we instead get negative 29, and that's nowhere near close. So keep plugging it in with your calculator. 96 divided by 4. That one works. Okay. So we got 96 divisible by 4. And if we take this, negative 24 times 4, that does in fact give us negative 96. If I add these two together, I get negative 20. Oh, there's the ticket. Okay. So negative 24x and 4x are our answers. So let's come over here and plug them in. Let's write them in a different color. Negative 24x and 4x. Okay. Now we need to find the combinations for the height and the base of our generic rectangle. So two numbers that multiply to 16x squared. Well, let's do 4x and 4x. Okay? 4x times what gives us 4x? 1 does. Okay? 4x times what gives us negative 24x? Negative 6 does. And then if we test our last one, 1 times negative 6 is in fact negative 6. So our factored answer is 4x plus 1 times 4x minus 6. Okay, now if you did this problem on your own, like you were supposed to, and you got to this point, you're probably looking at your notes and you're like, where did I go wrong? I factored perfectly, or at least I thought I did, or you're nodding your head agreeing with me, one of those two. Well, guess what? This one actually has two answers. I know, bit funky, but this one could be factored two separate ways. And the second way it could be factored is 8x plus 2 times 2x minus 3. Isn't that super strange how sometimes we can factor it more than one way? And guess what? I have fantastic news. They're both equally correct. There is no reason to favor one over the other. I just wanted to choose this problem so that you guys could see it is in fact possible to have more than one correct answer. Sometimes you can factor it more than one way. And just because you factored it the bottom way does not necessarily mean it's any less correct. So keep that in mind. I wouldn't worry about this too much. Just know that it's possible to have more than one correct answer. All right, we factored this one completely. We're going to go over one more problem because there's one more special case I want to talk about, and then we'll be done with the lesson. All right, class, so welcome to problem 4, and this is the one we're going to be factoring this time. 2x squared plus 4x. Now, these types of problems give my students a lot of pause, and here's why. Where's our third term, right? Where's c? It's not there. And we can still factor this using the exact same method. That's the great thing. Just because there's nothing there doesn't mean we can't represent nothing. In math, we have something to do that, specifically 0. So this works for if we have no last term, or even if you're missing this middle term, it's still 0. And we can still use our same method. So let's go ahead and start plugging things into our generic rectangle and our diamond problem, and let's take a look at it. So first we got 2x squared in our bottom left corner, and then we added the plus 0 on, which wasn't originally here, but this is allowed. Plus 0 changes nothing. So I'm going to put 0 up here. Then if we come over here, we have our diamond problem, and we still follow the same rules. So for the top, we're going to multiply these two together. 2x squared times 0 is 0. So that goes in the top, bam. And then we're going to take the middle term and we're going to write it just how it is, 4x. We're going to call it good there. Okay, now this one's pretty straightforward, right? I need something that multiplies to 0 but adds to 4x, okay? Well, there's only one thing that multiplies to 0, and it's anything times 0. So one of mine have to be 0, one of my answers, okay? 0 plus what equals 4x? 4x. Bam. Okay? And we're already done. Bring that over, 4x and 0 here. And now we still need to find the base and the height. So let's do that. What times what gives us 2x squared? Well, what about 2x and x? Okay? X times what gives us 0? 0. Bam. 2x times what gives us 4x? Well, 2 does. And now we're done. And we can bring that down here and write it out. So we have 2x plus 0 times x plus 2. And now we've factored it. We can simplify this one a little bit because 2x plus 0 is just 2x. So we can do 2x times x plus 2. Either of those work just fine as final answers. So this last problem really was just to illustrate to you guys that even if you're missing this middle term or this end term, you can still set up these problems. You just need to substitute in a 0 for the missing term, and then follow everything else just as it is. All right, with that being said, we're done with this lesson. If you guys need some more math help, or if you like just watching my videos, please subscribe. If you just want to support me, that's another great way to support me. Otherwise, I hope to see you guys in the next lesson. Thank you.